we're going to continue our study of the law of signs, the ambiguous case. Uh, we've had the lesson. What we're going to do now is begin to go over some examples that are in our practice for the test. Now, if you look at your syllabus, then we had on the syllabus that we would do the part of the homework out of the book that said to determine the number of possible solutions for the triangle. Now, we skipped that part of the lesson because we said you can figure out the number of solutions just by trying to do it. So we're not going to do that portion of the homework, which means on our worksheet, our study for the test, that we're going to omit number 5 and 6. And then also on the test, number 5 and 6 will be omitted. And so then that's going to bring us to number 7 on the worksheet, which looks like this. Now, I'm going to go ahead and write down problem number 7, but then I'm going to talk about a little something that to understand about how the calculator returns answers when you're plugging in to the calculator based on what we know is positive and negative in what quadrants and reference angles. And so what we're going to do here is we're going to think, okay, I've got little a and little b, and I've got angle A. And so I know that angle A is 58 degrees. Now, I really don't know if this triangle is acute, right, or obtuse. And so we're just going to go ahead and finish drawing it anyway, just so we can get an idea of where everything lies. So we're just going to say, okay, I've got angle A, angle B, angle C. Little a is opposite angle A, and little b is opposite angle B, and little c is opposite little c. And so we set that up, not knowing really whether it's acute, right, or obtuse, but we're just trying again to know what is where. Now, little a was given to us as being 26, and little b was given to us as being 29, and then again angle A was given to us as being 58 degrees. There's our given information. And so what we were given is in the order side, angle. Side, angle. And we know that side, angle is the ambiguous case for the law of signs. That means possibly we could have two different solutions. Now, we don't know yet whether there's going to be one solution or two. I'm going to go ahead and set it up as if there are two, and we would maybe need to get rid of this on the right later. This particular problem is going to have two answers, so I already knew that. Now, just because I've already made out the key, angle A is 58 degrees. That means if perhaps there are two options, then angle A is not going to change from option 1 to 2 because that was given information. Little a is 26 in option 1 or option 2. Little b is 29 in option 1 or option 2. There could be 0 solutions, 1 solution, or 2 solutions. Regardless, what we're given is not going to change. And so we were given that angle A was 58 degrees. We were given that angle A was 58 degrees. Little a is 26 and little b is 29. Now, the thing in this particular problem that is variable is really how long little c is. See, it's not locked in. And how many degrees angle C is. Now, we do know that if we were to stretch little our AB out longer, and then we lock that in, or, excuse me, if we put our little a here, then actually if we made AB shorter, then that would actually affect angle C, angle B, and it would affect little c. So that means that we could get a different answer for angle B, two different answers. We could get two different answers for little angle C, and we could get two different angles for little c. So in option 1 and 2, what was given, angle A, and little b, are going to be the same. What is variable in regard to, does this side end up here, or does this side end up here, would have an effect on the length of that third side, little c, the measure of the angle B, and the measure of the angle C. Since we don't know if there's 0 triangles, 1 triangle, or 2 triangles, what we decided to do is just go ahead and solve as if there's 2 answers. So we're going to get set up for 2 answers, and there may not be any. Now, I'm going to go ahead and start solving then. What we are given is A stuff and B stuff. That means that the first thing that we're going to have to solve for, since I'm given A stuff and B stuff, is angle B. So I'm going to set up a law of sines. I'm going to say sine of angle A, which is 58 degrees, over little a, which is 26, is equal to the sine of angle B, which I don't know, over little b, which is 29. And then I'm going to solve. So I'm going to cross multiply and get 29 sine 58 degrees is equal to 26 sine angle B. I'm now going to undo multiplication by division, so I'm going to divide by 26. And what that would do is cancel my 26. And so then I would have sine angle B is equal to 29 sine 58 divide 26. I'm going to go ahead and rewrite that just so we don't get confused. Sine angle B is equal to, I'm going to leave some space there, 29 sine 58 degrees over 26. Now I need to undo the sine, and I undo sine with inverse sine or arc sine. So I'm going to do inverse sine 29 sine 58 divide 26. Here the arc sine cancels sine, and we get angle B is equal to. So if we do 29, if we do inverse sine 29 sine 58 divide 26, we get 71.1 degrees. So my first option for angle B is 71.1 degrees. Now I'm going to go ahead and put it in green here just to kind of try to match. So 71.1 degrees possibly for the first choice of angle B. Now what we want to do is say, well, is that even possible for that to be true? Well, to check that, you would need to check to see if angle A and B add up to 180 or more than 180 already. If they do, you can't even have a triangle. If they don't, that means there's enough room for angle C. If they don't add up to more than 180, so to get our angle C, we could take 180 minus 58 minus 71.1, and we would get that angle C for my first choice would be 50.9 degrees. And then we would say, okay, there's my first choice. Now let me explain just a moment this. I drew the picture, and we know that this possible angle B and this possible angle B are supplementary. They add up to 180. So to get the second choice, we would go 180 minus the first choice. Now that's looking at this picture that we've got drawn. that this angle and this angle, the two possible angle B's, are supplementary. But let's go back to the unit circle or the coordinate plane, and let's think about this. If we have some angle, angle B, in quadrant 1 where they're all positive, that means that there's also an angle that's less than 180 in quadrant 2 that's 180 degrees minus angle B. In other words, this second angle would be an angle that has a reference angle of 71.1 degrees. The first angle, the first choice of our angle B, is in quadrant 1. The second choice of our angle B would be in quadrant 2, but its reference angle is back to the one we had in quadrant 1. And so to find our angle in quadrant 2, it would be 180 minus our reference angle, you see. And so there's two ways to think about the fact that the second choice for angle B is 180 degrees minus the first choice for angle B. And 180 minus 71.1 gives us a second choice for angle B of 108.9 degrees. That is an angle in quadrant 2 whose reference angle is 71.1 degrees. Now, if you were to go to your calculator, the sign of the same number, both positive, will give you 71.1 and 108.9. But if you put it in the calculator will always return the smallest possible angle. So even though if you did inverse sine some fraction, the answer, as far as an angle that could be an angle of a triangle, would be 71.1 or 108.9. Since sine is positive in both quadrant 1 and 3, then the same fraction with the same sign would return either 71.1 or 108.9, but the calculator will always return the smallest choice possible. So the calculator is going to give us the 71.1, and we have to know that it has a reference angle in quadrant 2 that's 108.9, you see. Okay. We'll talk about this more when we deal with the law of cosines in lesson 30. You'll see why I'm bringing that out here. All right. Now, when option 2 for angle B was 108.9, that makes the second option for angle C 180 minus angle A of 58 minus the second option for angle B, which is 108.9, and it did leave enough room for another angle C of 13.1 degrees. That means that in this particular scenario, there's two possible solutions. The one possible solution would be this whole big triangle, which would include this angle B, or this little triangle here, which would include this angle B. Okay? Now, we have established the two choices for angle B, and we have established the two choices for angle C. The only thing that we haven't established are the two values for little c. And so what we want to do now is show you how to find the two possible choices for little c. Now, we're going to use a law of sines, and so we're going to say sine of angle A, 58, over little a, 26, is equal to sine of angle C choice 1, 50.9 degrees, over little c choice 1. I'm just going to put c sub 1 if that's okay. We'll call this c sub 1 and c sub 2 for right now. Okay? Let's go ahead and solve that one just so we have enough board space to get the job done. So we're going to say little c choice 1. And then we're going to cross multiply, and we're going to have sine 58 degrees times choice 1 for little c is equal to 26 sine 50.9. And then we want the stuff off of little c, so we're going to undo sine 58 by the multiplication of sine 58 by dividing by sine 58. And we're going to get that the first choice of little c is 26 sine 50.9 divide sine 58, and we're going to get 23.9 for our first choice of little c. Okay? 23.9 for our first choice for little c. Now, to get our second choice for little c, we do the law of sines again. A doesn't change, so sine angle A, 58, over little a, 26, is equal to, now we go to the second choice of angle measures for angle C, which would be sine 13.1 over little c choice 2. I'm just going to call it C2. So to solve, we're going to cross multiply. We're going to get sine 58 degrees times C2 is equal to 26 sine 13.1. We want the junk off of little c, so we're going to undo multiplication by division. So we will divide by sine 58. And so we get little c choice 2 is equal to 26 sine 13.1 divide sine 58, and we get 6.9 for our second choice of little c. Any questions on the law of sines, the ambiguous case? So in this particular problem, we have two possible solutions. Again, notice that what was given was little a, little b, and angle A. And so even in our two choices, angle A, little a, and little b are not variable. What was able to vary was the measure of angle B, two choices, the measure of angle C, that whole big thing, or that angle, two choices, and the length of little c, which is equal to the whole bottom if we had the big triangle, or just this little piece right here if we ended up with the little triangle. Any questions on the law of sines, ambiguous case?